Yeah. I pass the word to Rafael Ostetler, who will speak about Roboy and Devanthro. So, welcome, Rafael.
Okay, so welcome. Thank you for inviting me. It's a pleasure to be here. I'm going to talk about Devanthro Society, and that's basically what happened since the last Shanghai lecture about Roboy, which was in September 2012, before Roboy was even completed by Pascal. Devanthro Society is the Society for the Development of Anthropomimetic Robots, and basically, to put this in shorter words, it means I want to build a robot that is as good as my body. There's many reasons to do this, but I think it's a good goal, a good target to converge to. And how do we want to achieve this? So this is a long-term vision, of course. It's not something I'm going to do, or we are going to do in the next 5 years. It's more something like, I don't know, 50 years or 100 years. So we need a long-term strategy. So of course, we need to talk with research. We want to engage in research with the Roboy project and Devanthro. We want to motivate young students to actually choose subjects that are relevant to our focus. We want to communicate with the wider public to basically explain to them that robotics is not a danger, or where it might be a danger and where not. And we try to build a community around the project. And where we can, we try to accelerate it through commercial exploitation. So when we see something in the project that works nicely, we try to build a spin-off that forward and then reintroduce the results that are relevant into the society. So where do we come from? History. You've seen these graphics before today. And also this, so it's about embodied intelligence. The whole thing started, one might just say, also in Rolf's lab and University of Sussex with Kronos, which is the first of these robots where they thought, okay, let's just not build a robot that looks like a human, but that also tries to imitate the way it functions. So that has muscles and tendons. This was then improved in a second version, and if you've seen Edge ADS, the second one moving, it's quite fast and interesting to see. But it was very hard to build. It took, from what I know, a few years to actually build it. And of course, if you're a researcher and want to do modeling and control, waiting a few years for your hardware is a bit tough. So the end of the EdgeBot robot, Anthrop, was being built. It's classically designed. It's classical engineering. It's a CAD design. It's using modern printing techniques such as 3D printing or stereolithography. And laser sintering, and then actually the real thing. And this is a project that only took a few months compared to a few years. So it was a good way now that we had to develop these kind of robots, or that they had. I wasn't part of this then. And in June 2012, we really thought, okay, we need a messenger, and also Rolf's lab turned 25, and there was this huge show announced, the Robots on Tour, and there was just 9 months to complete a robot, and we thought, well, we really need a robot that, or the AL lab needs kind of something to show and make a huge impact. And so the goal for the project was to build an ambassador for a new generation of robots, of a soft robot that is has a humanoid shape, that should share his living space with humans. So he needs to be interactive, right? It can't be one of these robots that you have to put a rope around to protect on standards. So people need to be able to touch it, to interact with it. It should evoke positive emotions. So there's always this danger that people are frightened or irritated by robots, and we try to avoid this by making it very cute and kid-like. Because, of course, this kind of emotions that we attach to kid-like proportions help alleviate fears and similar things. Another, of course, it should be a research platform, not a product. It's a project where people should interact and push together forward, and it should be easy to reproduce. So that's one important thing. That's also one of the reasons why we're using 3D printing, and it should be very fast in development. We had this 9 months and until the AI lab turned 25, and well, I'm glad they managed. And of course, it's open source. It had to be open source. Everyone can contribute to the project. It's about creating a community. So then it started. I was part of the project this together with an artist at Disney Research, Maurizio Nitti. Did first design sketches. We iterated a bit. We found an idea that we kind of liked. The question then was, well, is this cute? Of course, this is not really the goal, or didn't really work, and that's where it already started, where we think, okay, well, of course, we want to see. We could just change its head, but we could also just ask what's the best head. So we started creating a community. There was a Facebook voting where people could basically vote which kind of head Roboy should have, and that's the result. And then a few months later, the cat design was complete, and there were many people working in this. So it was only possible thanks to a lot of sponsors, a lot of companies that put a lot of hard work into it, because in 9 months, I mean, we cannot fund this through a research grant from the start. But it was certainly very hard. And then again, it's about creating a community in order to pay for this, because while a lot of these companies that we've just seen are very happy to give us, or were happy to give us, maybe 70% reduction, it still meant we had to find the other 30% from somewhere. So we did the crowdsourcing. You could basically buy your name on Roboy or your logo, and it was interesting. There were about 50 companies and a lot more private persons. And that's how Roboy looked right after its inception. It was covered by names and logos, and this was what made it possible. So eventually he was done. And of course, once he's done, we need to analyze, is this a good messenger? Was it worth the effort? And of course, this wasn't not only due to Roboy, but also to the other eating robots that were there. But at the Robots on Tour, people were queuing for 3.5 hours. Which was certainly not planned, but it was, of course, showed how much interest there really is in the public about these topics, and that I really want to see robots, and that is something that people are deeply interested in. And also the media coverage we've been to. There's about 5 to 6 full-length shows that basically feature Roboy, and then there's a lot of smaller things where Roboy is in. We've also been to TV Total, which is a German comedy show. So we really tried to get it out. We've been touring Europe, a lot of events, of course, in Zurich. That's where he comes from. So, but also in Nuremberg, we've been to Berlin by now. We've traveled to China. We've traveled to Washington. And we're going to Doha, to the ITU summit next week, where Rolf will have a great introduction about these topics.
This week, not next week. This week.
Well, you will travel. Well, that's actually true. Yeah, it's still this week. It was a test whether everyone is listening. Yes, this week, and. So we've been to Cebit, where we've been named the star of Cebit, which was pretty cool. Making it visible has certainly worked quite well, and this helps us to talk with the public and explain to them about robotics. And how do we do this? I mean, of course, one thing is through the arts. When Roboy was introduced, we've developed with an ensemble of artists a theater play which presented Roboy. When we were in Beijing, we also had an ad hoc theater play. We were in Shanghai. We had this great collaboration with Professor Chen where we put Roboy in his autonomous wheelchair because Roboy cannot walk, and this was a very great encounter where all these young children really could interact with Roboy. Later on, the only dangerous moment was when that child was approaching Roboy with an ice cream. But yeah, and also we go to conferences and these more inspirational events. We've been to 3 TEDx so far. So that's how we basically talk with the public. And the other thing is to create engineers. We need to create people that want to work on this in the long term. So we founded the Roboy at School program, where it's basically a program that Roboy goes to a school for a whole day. There's 4 lessons, which or 4 modules, which are taught to 4 classes in parallel, so we can have 4 classes enjoying a whole day of robotic interaction. The first is about social impacts of robotics, the ethical questions behind it, the question whether I need to fear for my job, questions whether I need to be afraid of AI, questions I need to be afraid of robots another way, and so on. Then there's about anatomy, where what's similar to in Roboy to the human body, what can we learn from it, what can we learn from the human body to build better robots. Then the general topic about how do I actually go forward. So let's say I have the idea, I want to build a product or a Roboy, and what do you need to do to basically have it in the end to achieve this. Also about 3D printing, different technologies, what can you use, what are the up and down signs, and of course in the end there's a robotic building challenge where it's very embodied, because the teenagers, they get a robot or a motor that's oscillating, so it doesn't have any direction. But they can use all sorts of hot glue and shashlik sticks and wire and carton and so on, and to build robots that basically break this symmetry and move forward. And then there's, I think my screen sharing just broke down. Okay, it's back. Okay. Yeah, so that they build these robots, and they really need to understand that the body of the robot is what matters and not the control, because it's basically just an oscillating servo, right? So that is one of these examples that has been built. We could now discuss whether this is a good solution or not. It turned out to be not so good. There were some quite interesting things going on, and it was very interesting also to see how they were interacting with this kind of task. We also tried this at different ages. At what age is it basically possible? When do they better understand this kind of questions? And so about research. So I'm part of the My Robotics project, which is basically a project that is very similar to Roboy. So we're trying to build musculoskeletal robots, but now in a modular fashion. So instead of having a completely designed robot, we try to split it up in parts and let the user basically assemble it and whatever configuration is required to solve a task. So basically consists of joint modules, which provide joints to user freedom. These muscle modules who are series elastic actuators with a slight nonlinearity in the spring. And then we have the bones, which of course are what bones tend to do. They provide the structure. That's the first video for Nathan. So basically, this is one small example why this is interesting. This is just a P controller trying to maintain an upright position. But you can see how we can use this very simple controller to do things like throwing balls, use the stiffness in the spring to store energy, all these kind of things that's impossible with a different kind of mechanics. And basically, My Robotics is a system to explore these complex dynamics. Of course, one can also build larger things. As you can see here, it's our quadruped. That's the second video.
1 amp, 1.8 amp. Looks good.
So, of course, this is much easier if it's not on the ground. but it's just recently been completed, and for me, as people are working on controlling it. And it's, of course, an interesting system. So we can build robotics arms. We can use the same system to build a quadruped. We are currently taking parts of that system to build new legs for Roboy. For example, because the bone structures is not perfect to build new legs, it doesn't really fit the style of Roboy. So we've developed a new hip and new foot, new feet, new joints, but we basically keeping the motor units and the electronics that has been developed in and some of the joints in my robotics project. So it turns out to be very, very flexible and a very interesting system, because there's also software accompanying it where you can simulate it and do the control. Also because we have this very interesting properties, so that we have bio-inspired bodies, so to say. It's interesting to think about, well, why don't we just use bio-inspired control on the other side? And our lab in Munich here is luckily part of the new Robotics EU project. And we're currently fusing our MyRobotics robot with large neural networks, with models, cerebellar models, in order to try to control them. We're using Spinnaker for this. This is a neuromorphic software. It's basically chips, dies that have a lot of ARM cores in it, which are under special routing that makes it very easy to transport spikes around and efficient relation of point neural networks. And our current state is that we have it connected, it works, and but it doesn't do well. It sort of works. We're still tuning and trying to find the perfect properties for the network. Another important thing, Roboy is open source. As I said in the beginning, this is what we think a key thing to build a community. So it's on GitHub. You can just download whatever part of it, the current state of the software, his CAD design. It's in a very permissive license, so it's BSD3 clause and for the code and CC BY 4.0 for the CAD. And basically this license only restricts you to mention us if you use it and make derivatives of it. But apart from that, you can even use this thing commercially if you choose to do our parts. This brings me to the next slide. It's the commercial detour. We've been looking at the Roboy project and thought, well, wouldn't it be interesting, or what parts can we take and use to accelerate it, because it's almost close to a commercial implementation, and it's basically its head, because the head, it doesn't, in terms of hardware, it doesn't require a lot of research. It's building a product, so we're working on a new and mass-producible head. So whoever is interested in human robotics interaction, it might get interesting. But we're really trying to make it a product that is commercially viable outside of research. So the idea is we want to build an intelligent agent that can be placed wherever you would like to have a person, but it's not viable to have someone there because of cost reasons. For example, you probably all know the situations. You have an appointment somewhere in a company, and you go to a side entry, and you're greeted by a locked door and a phone, and you try to call up the person you have an interview with or whatever. But it's generally a kind of a unpleasant situation, and we want to put Roboy there, and it would recognize you if it's not the first time that you're there, and basically create the connection to the person you have an appointment with. Or the second use is hospital floors, where you can. Very often people get lost in hospitals, and they're looking for patients, or patients are looking for treatment places, or certain doctors, visitors looking for their loved ones, and so on. And it's often information that is also not known to the personnel, just on top of the head. But having a robot system that basically knows all this kind of information, and you can just ask, "Oh, dear Roboy, where did they move my aunt?" And well, he would certainly be able to work on that. So in conclusion, with Devanthro Society, we try to build the best robot in the world. And we do this by supporting research, as for example, right now in the My Robotics and Human Brain project. We try to motivate young students for the STEM subjects through Roboy at school. We communicate to a wider public to reduce fears of robotics and prejudice through fairs, events, and conferences. We try to build a community through the fact that Roboy is an open source project, and we try to accelerate it through commercial exploitation through the company AI technology that we've built. Finally, also, it's an open project, so we need the support. If you're interested, if you have an idea, what could we do with Roboy, how could we bring it further? We're also doing a lot of bachelor, master thesis. So also, if you have an idea, we can also cooperate on this. This would be very great. And so, finally, let me say, welcome to the future, Rolf and Roboy in the car, and thank you for your attention.
Thank you.
Questions?
All right, we have a question from Plymouth.
Yes.
Yeah. Thank you very much for a very nice presentation. And I think the robot is a really cool robot. I also think a lot of groups, at least in our group now, we're thinking like, oh, so how can we build one ourselves? Can you give an estimate about the type of costs and efforts that's needed to build one now, and how would we go about it if we wanted to?
So right now it's just replicating Roboy is considerable, which is also part of why we work with My Robotics, because that's much cheaper. There, a muscle currently is around 800 euros. So if you want to build an arm, you can do this for about 15, 20. How we can disseminate this in an easy way, because we want to make sure that this is possible, because there is, of course, it's a very, I personally think it's a very nice system and very interesting as well. In terms of Roboy itself, the head, if you're interested in having a nice robotic head that can and so on, this will probably not become, I mean, you can replicate the current head, that's not a problem, this works very well, we can get all the parts. But our new head, which is also the one that we want to commercially use, will probably not be commercially viable before the end of the next year. This is where it's a product development. If there's interests, we could, of course, talk about having a cooperation that starts earlier with a beta version or even alpha version when we have first prototypes that we are certainly interested in as well. And also, what we can do is, of course, doing things remotely. And I'm very interested in moving. So currently, Roboy uses its own custom software. But I'm very interested in really moving all these software parts that we have right now into one framework. At the Human Brain project, they're using, I always forget its name. One of these, I'll come to it. And Gazebo, yeah. So they're basically working with Gazebo, and our plan is to get our models into Gazebo. And of course, if there's interest in working on this, this would be great, because it would make dissemination. That's also what made it a bit hard so far to really build a community around Roboy. That the entry-level hurdle is quite high. But,
all right, thank you very much.
But let's talk about it, I mean.
There is a question from Madrid.
Yes.
Well, first of all, thank you for the presentation. As Martin said, it's very interesting, and your work is really cool. My question is, have you done any kind of study with participants about how people behave when they are interacting with this robot, with Roboy?
Not yet. We're currently working on setting this up with Martina Mara from Austria, but we're really interested in this because I personally think it's a huge untapped potential. Roboy goes to events about once a month, so to a larger venue, and if you had good protocols, we could use each of these events to make some study. So if you have experience in this, we should really talk about it. We're really interested in that. Because personally, I mean, I'm more of a control and building and organization guy and less of I don't know enough about human robotics interaction research to really do it. So yeah.
The key point in this kind of robots, just to study how people will react when they are playing or talking to the robot or asking questions or things like that. Thank you for your answer.
Thank you.
So, if you don't have other question, I think we can move to the presentation. So we can thank again Rafael for a very interesting presentation. And